have the Wii controller. I'm changing your station, or whatever you do with this thing. I don't know. Okay, hi geometry class. It's been a while since we've had a video. Hope you had a lot of turkey. This is proof section. Woohoo! All right, we have two proofs to go over. First one is on page, what page is this one on? 117. I want both proofs in your notebook, and there's a little section called a way to prove two segments or two angles congruent. That's on page 118. That needs to go into your notebook as well. I will be checking tomorrow, so hop two. Okay, given, we're going to do two proofs, and then I'm going to, given A, B, and C, D bisect each other at M. Every time you're doing a proof, you got to plan. You got to make some plans. And you also have to figure out what is the given telling you. And also you have to figure out what are you trying to prove. So if A, B, and C, D bisect each other, bisect means cut in half. So automatically you should say, okay, AB is going to be cut in half at M, and CD is going to be cut in half at M. So guess what? I know that AM and MB are going to be equal. And DM and MC are going to be equal. Wow, we're already showing some things here that we can prove. Look at this. I've got two sides. What do you know about those two angles? Those are vertical angles right there. But what do we have to prove? We have to prove that AD is parallel to BC. So remember what I said in class today. How do you prove things parallel? Alternate interior angles, corresponding angles, if they are congruent, or if same side interior angles are supplementary, then you can prove that the lines are parallel. So that's what you have to be able to use. Okay, so let's see. We're going to say that AB and CD bisect each other at M. That's given. Now, I just showed you that AM and MB are congruent, and BM and DM and MC are congruent. Definition of bisector and definition of midpoint. Okay, so I've got those two. I've got two sides. Then look at this. Angle AMD is congruent to angle BMC. Vertical angles are congruent. Okay, I'm going to draw in my little congruent sign. Boom! I already know that these two triangles are congruent because of SAS. Okay, side angle side. So triangle AMD, make sure you get it in the right order, is congruent to triangle BMC. So we've already talked about the order of the letters. That's by side angle side. I know the two triangles are congruent. Therefore, all the corresponding parts of the congruent triangles are going to be congruent. I think I'm going to be able to use alternate interior angles here. Let's see. If I can prove, well, let's see the way they did it. A is B. Okay, that's exactly what I would have done. So they said angle A is congruent to angle B because corresponding parts of congruent triangles are congruent. And therefore, if you notice, these two lines are going through, and this is your transversal. Again, not a great picture from me, but you've got two lines, and you've got alternate interior angles are congruent. Therefore, AD and CB are parallel in the proof. And this is all on page 117, so you can copy it right out of the book. Angle A and angle B are congruent. Corresponding parts of congruent triangles are congruent. And then AD and BC are parallel alternate interior angles. Okay? That's fun, isn't it? Okay. Now, we've got example 2. This one's a little more difficult to draw. I do want these drawings in your book. Just do your best. I had a hard time drawing it myself. You know my drawing skills anyways. So, given PO is perpendicular to the plane X. Here's my plane X. The girls are laughing over there. Here's PO. So PO is perpendicular to X. AO is congruent to BO. Okay? So here's AO and here's BO. And we know this is congruent to the plane. So we've got like a line and it's sitting on top of a plane. It's hard to see in my picture. But this is going to be perpendicular to this plane, which A and B, these lines are on this plane. Okay? So we have to prove that PA is congruent to PB. So we're going to be proving this and this are congruent. So how are we going to do that? Look there's a common side in this triangle with that triangle, so I'm probably going to do something with that. I've got two perpendicular angles right here, probably going to do something with that. Okay, and I already know those two, so look at that. We can already see what's starting to form here. So the first thing is given, PO is perpendicular to plane X. So I can say that PO is perpendicular to OA. If you look over here, PO and OA are perpendicular, and again, this is a plane, that's like a 3D thing coming out of it, so it's hard to draw. But PO and OB are perpendicular, definition of perpendicular lines to a plane, of a line perpendicular to a plane. The measure of angle POA equals the measure of angle POB. Those are the two angles we were just talking about. Definition of perpendicular lines and definition of a right angle. So then I could say AO is equal to BO, congruent, because that's given. I already drew the little symbols in there. PO is congruent to PO. This is what you guys missed the other day on some of you missed, not all of you, on the bonus question the other day. PO is congruent to itself. What do I have here? Whoa! Side, angle, side, because I know this is congruent to that. Okay, so I can see POA is congruent to POB. The triangles are congruent by side, angle, side. And then finally, I can say PA is congruent to PB because corresponding parts of congruent triangles are congruent. Okay, so keyword today is weak controller. On page 118, there's a section called a way to prove two segments or two angles congruent. I want you to put that in your notebook. And that's about it. Have a great night. See you tomorrow. Bye.